We will learn how to install rock bolts in underground tunneling and mining.
So, you're out there every day installing rock bolts. You know the drill, you know the process. But today, we're going to go a little deeper than just the how. We're really getting into the why. This is all about understanding the science behind the system you're building. Because let's be honest, getting this right is what keeps the ground above you, well, right where it's supposed to be. Let's jump in. Okay, take a hard look at this. This right here is a catastrophic failure, and it's called gloving. You see how the plastic from the resin cartridge has just completely wrapped itself around the bolt? That means the resin never actually bonded to the steel. It's literally like trying to glue something with the wrapper still on. This bolt is doing next to nothing. And you know the scariest part? From the outside, it probably looked perfectly fine, and that right there, that's what's at stake. So here's what we're going to cover. First, we'll talk about why rock support is your first line of defense. Then we'll compare mechanical and resin bolts. After that, we're going to dissect what a failed bolt actually looks like. From there, it's all about mastering the installation. And we'll wrap up with the one big idea that ties this whole thing together, thinking of it as a complete system. All right, let's start with the big picture. Every single bolt you install isn't just a piece of hardware. It's a critical part of a massive system that holds the entire mine together. You're not just filling a hole in the rock. You are literally building the primary structure that prevents a collapse. And look, let's be real. The consequences of getting this wrong are huge. When a bolt fails before it's supposed to, it's not just some operational hiccup. It is a direct threat to the stability of the entire mine and, way more importantly, to the safety of every single person down there. What you do bolt by bolt is what makes a shift safe. Okay, let's talk hardware. You know that not all bolts are created equal. You're mostly dealing with two big categories, mechanical bolts and resin-anchored bolts. Really understanding the difference between them is the absolute first step to nailing the installation every single time. This table breaks down the trade-offs perfectly. You've got mechanical bolts. They're quick, they're simple, great for hard rock, but their big downside is they can loosen up with vibration. Now, resin bolts are kind of the opposite. They're fantastic for weaker, jointed rock, and they laugh at vibration. But here's the catch. Their strength is 100% dependent on a perfect installation. And that's the critical part, isn't it? It's where things can go sideways. And this right here shows you exactly what we're talking about. On the left, you've got the mechanical bolt. See that expansion shell on the end? When you tighten it, that cone gets pulled in, forcing the shell out to physically bite into the rock? Simple. But on the right, the resin bolt, it's a completely different game. Here you're creating a chemical glue, a bond, along the entire length of that steel bar. So think of it this way. One is a mechanical grip, the other is a chemical weld. So, since a resin bolt is only as good as the install, let's get smart about failure. To really get this right, we first have to become experts in what goes wrong. We're going to look at those hidden mistakes that can turn a high-strength anchor into just another useless piece of steel in the wall. Yeah, we saw this at the very beginning. The official name for it is gloving, and it is public enemy number one for resin bolts. It happens when the bolt spins up but doesn't properly shred that plastic cartridge. That plastic then forms a sleeve, a little glove, right around the bolt. The resin can't touch the steel, the bond can't happen, and your anchor is basically useless. And that analogy, it's perfect. It's a glue job with the wrapper still on. So the big question is, how do you stop gloving from happening? Well, it all boils down to one key idea: centralization. It's just about keeping the bolt perfectly centered in the hole. When a bolt is centered, the resin mixes evenly all the way around, and that means you get a stronger bond, better stress distribution, and it even protects the steel from corrosion. And this is exactly what happens when you lose that centralization. The technical term is eccentricity. Just look at these cross-sections. You can see the bolt is shoved way over to one side of the hole. This creates this huge gap on the other side. So when you spin that bolt, the resin cartridge just gets pushed into that empty space instead of getting shredded and mixed properly. This right here is the root of the problem. And boom, here's the direct result of that off-center bolt. This is looking down the length of a failed bolt. You can literally see the streaks of unmixed resin and that plastic glove that's sleeved the rod. The chemical reaction that's supposed to create this super strong bond, it just never fully happened. This bolt has a massive, hidden weak point running right down its spine. Okay, enough doom and gloom about the problem. Let's talk about the fix. How do we make sure we get a perfect installation every time? Well, the good news is there are specific techniques and even new technologies designed to completely eliminate these failures. This right here, this is the aha moment.
On the bottom row, that's what you get with a standard 45-degree tip bolt. Looks familiar, right? It's off-center, you've got voids, you've got poorly mixed resin. Now just look at the top row. This is a bolt with an innovative tri-lobe tip. I mean, the difference is night and day. It's perfectly centered. The resin is completely and consistently mixed. This is what a successful installation is supposed to look like on the inside.
So how does it work? It's actually pretty clever. The tri-lobe tip does two things perfectly. First, its shape just automatically centers the bolt in the hole. No guesswork. And second, as it spins, it acts like an auger, shredding that plastic and pulling it all the way to the back of the hole, where it wraps it up harmlessly around the tip. So with this one design change, you solve both problems at once, the eccentricity and the gloving.
So let's put this all into a simple mental checklist. Number 1, ensure centralization. Using a better bolt design like the tri-lobe tip is the easiest way to do that. 2, respect the resin annulus. That's just the gap between the bolt and the wall of the hole. It has to be what the manufacturer says it should be for the resin to mix right. 3, obey the mixing times. Don't overspin, don't underspin. Overspinning can actually tear apart the resin as it's trying to cure. And finally, number 4, a simple but vital one. Check the shelf life on your resin cartridges. Expired resin is just not going to perform.
Okay, let's pull all of this together with one last really important thought. This is the mindset shift that separates the good installers from the truly great ones. This quote from the research just nails it. You're not just installing a bolt. You're not just using a resin cartridge. You are combining the tendon, the resin, the borehole, and the rock itself to create a single, integrated support system. Every single one of those parts has to work with the others perfectly. The bolt design has to work with the resin, and the resin has to be right for the rock. So I'm going to leave you with this one question to think about on your next shift. When you pick up that bolter, are you just putting a piece of steel in a hole, or are you consciously, carefully building a complete, integrated ground support system? The answer to that question makes all the difference in the world. Stay safe out there.